Hello everyone, and welcome back to our SecurityX course. In this lesson, we'll explore two main areas: software assurance and continuous integration and continuous deployment. First, let's dive into software assurance, which encompasses a range of practices aimed at ensuring the security and reliability of software throughout its development and deployment. Static application, security testing. Static application? Security testing is a method of analyzing source code for vulnerabilities without executing the program. SAS tools examine the codebase to identify potential security flaws, such as SQL injection points, buffer overflows, and insecure API usage. Moving on to dynamic application security testing, DAST, this approach involves testing the running application to identify vulnerabilities that may not be evident in the static code analysis. DAST tools simulate attacks against the application in its operational state, uncovering issues like runtime vulnerabilities, authentication weaknesses, and insecure data handling. Runtime application self-protection. Runtime application. Self-protection takes application security a step further by embedding security directly into the runtime environment of the application. RASP tools monitor and analyze application behavior in real time, detecting and mitigating threats as they occur. Unlike traditional security measures that rely on external analysis, RASP provides immediate protection against attacks such as injection flaws, cross-site scripting, XSS, and unauthorized access attempts. Next, let's explore continuous integration and continuous deployment, CI/CD, which are essential practices for modern software development, enabling rapid and reliable delivery of applications. Integrating security into the CI/CD pipeline ensures that security measures are consistently applied throughout the development process. Coding standards and linting. Coding standards and linting are foundational elements of secure software development. Establishing and enforcing coding standards ensures that developers adhere to best practices, reducing the likelihood of introducing vulnerabilities into the codebase. Linting tools automatically analyze code for syntax errors, code smells, and adherence to coding standards, providing immediate feedback to developers. Branch protection. Branch protection involves implementing policies and controls around the use of version control branches to prevent unauthorized or insecure code changes from being merged into critical branches like main or production. This can include requiring code reviews, enforcing passing build statuses, and restricting who can approve and merge changes. Continuous improvement is a mindset that emphasizes the ongoing enhancement of processes, tools, and practices to adapt to changing security landscapes and organizational needs. In the context of CI/CD, continuous improvement involves regularly evaluating and updating security measures, integrating new security tools, and refining existing practices based on feedback and emerging threats. In summary, implementing security in the early stages of the system's lifecycle and throughout subsequent stages is vital for creating resilient and secure network infrastructures. Thank you for joining us today, and see you next time.